Hello my dear students. In the today's class, we will solve some of the problem related to an error and accuracy. Now look at the problem number 8. Here an ammeter is used for the measurement of 20 milliamp current. The reading obtained in the meter is 19.85 milliamps. So that determine the absolute error, percentage of relative error and relative accuracy. Now look at the solution for this problem. Here the first parameter which we have to measure, that is absolute error. We know that error can be defined as the difference between true value of the quantity with the measured value or observed value of the physical quantity being measured, so that it can be expressed as ES is equal to YN minus XN, where ES is called as absolute error. That means here absolute error can be denoted as small es. YN stands for expected value or true value. In this problem, the true value or expected value is 20 milliamps. Similarly, here Xn is equal to measured value or observed value. In the given problem, the measured or observed value by using a meter is 19.85 milliamps. So that substitute the value of Yn and Xn in the given equation. Here Yn is equal to 20 milliamps and Xn is equal to 19.85 milliamps, so that absolute error ES becomes ES is equal to 20 minus 19.85. After calculation, absolute error ES becomes 0.15 milliamps. This is how we have to solve the absolute error in the given problem. Now the next parameter which we have to measure, that is percentage of relative error. Here you can see the percentage of relative error can be denoted as percent small er. Here small er indicates the relative error and the unit is in percent. Here the relative error can be expressed as ER is equal to absolute error divided by true value. This is what the equation for relative error. Now here absolute error is denoted as small es, and we know that absolute error ES is equal to Yn minus Xn. In the previous slide, we have already found the value of absolute error, that is 0.15 milliamps. Similarly, here true value or expected value can be denoted as Yn, and the value of Yn is 20 milliamps. So after substitution of the given parameter in the equation number 1, ER becomes ER is equal to ES divided by Yn. Here we know that ES is equal to Yn minus Xn. So substitute in the equation, so that relative error ER is equal to Yn minus Xn divided by Yn. Now in the given problem we know that ES is equal to 0.15 milliamps and YN is 20 milliamps. Substitute the value here. You will get 0.15 divided by 20 milliamps. Now after calculation your value for relative error ER becomes 0.0075 milliamps. This is how we can find the value of relative error. Now it is important to find the value of percentage of relative error. It can be expressed as percent ER is equal to ER into 100. Here we know that ER is equal to relative error and the value which we have found earlier, that is 0.0075 milliamps. Now in the equation number 1 substitute the value of ER so that we will get the percentage of relative error is equal to 0.0075 into 100, that is equal to 0.75 percentage. So that we can say here the percentage of relative error is 0.75%. This is how we can find the value of percentage of relative error in the given problem. Now the next parameter, that is relative accuracy. Here accuracy can be denoted as capital A and it can be expressed as capital A is equal to 1 minus relative error. We know that relative error can be denoted as small er, so that accuracy A is equal to 1 minus er. Consider this as equation number 1. We know that ER is equal to relative error that we have found earlier. The value of relative error is equal to 0.0075 milliamps. Now substitute the value of relative error in the above equation so that A is equal to 1 minus 0.0075. Now after calculation, accuracy or relative accuracy A is equal to 0.9925 milliamps. So that relative accuracy capital A becomes 0.9925 milliamps. This is how we can find the value for relative accuracy in the given problem. Suppose if you want to find the value of percentage of accuracy, then how we can express the percentage of accuracy in the given problem? It can be expressed as percent A is equal to A into 100. Here capital A is the relative accuracy. So we know that here relative accuracy or accuracy capital A is equal to 0.9925 milliamps, which we have already calculated. Now substitute the value of relative accuracy, that is 0.9925 milliamps in the above equation. So the percentage of accuracy is equal to 0.9925 into 100. So that here the percentage of accuracy in this problem is equal to 99.25%. So that we can say the percentage of accuracy is equal to 99.25%. This is how we can find the percentage of accuracy in the given problem. In the next class, we will solve the similar problem. This is what end of the presentation. Thank you and see you in the next video.